Now that I probably scared you in the last video, I'm going to do the definite integral from 0 to pi of 10 times the cosine 4 raised to the 4th power of x, okay, dx. So I am actually going to rewrite the cosine up to the 4th power, or the cosine of x to the 4th power, as the cosine squared of x squared, which means that I can actually now use my favorite trigonometric identity and plug in 1 plus the cosine of 2x divided by 2, okay, and I can just square that, and that is the equivalent of each other. So I'm going to go back into our problem and just substitute this. I'm going to rewrite this as 10 times our integral from 0 to pi, okay, of this right over here. So I'm going to have a 1 plus cosine of 2x all over 2, square this dx. Alright, now I'm going to simplify this. I'm going to pull that 2 out as a 4, so it's going to be a 10 over 4. We're going to get a 5 halves. Okay, the integral from pi to 0 to pi. Alright, which will leave us with our 1 plus the cosine of 2x dx. Square that. Okay, so I'm going to actually bring this out here. Okay, and I'm going to do 1 plus the cosine of 2x times 1 plus the cosine of 2x. And this is going to give us 1 plus 2 times the cosine of 2x plus cosine squared of 2x. So we successfully reduced it from the power of 4 down to a power of 2 now. So we're going to have to probably back substitute our cosine squared of 2x again, and with what we have here, this identity I brought up at the beginning of the problem. So with that being said, now we're going to set this equal to, okay, so 5 halves, the integral from 0 to pi of 1 plus 2 times the cosine of 2x plus cosine squared of 2x dx. Alright, now I'm going to rewrite this problem so that we can have it in terms of multiplying it all, or I'm sorry, adding it all together, adding just a sum of a bunch of integrals. So I'm going to set it equal to 5 halves times all of the integrals from 0 to pi, okay, of 1 dx plus 2 times the integral of cosine 2x from 0 to pi dx, okay, plus, alright, so now we're going to have this cosine squared of 2x. We're going to want to set the integral of this. We're going to want to use our trigonometric identity again. 1 plus, the one that we, instead of rewriting it, I'll show you that the one that we used up here, nope, that's not working. The one that we used up here, okay, let me just mark that out. 1 plus cosine 2x over 2 is going to equal cosine squared of x. So we can get rid of that power, and so we can just do our integral as a sum of integrals. Okay, so plus, I'm going to have my 1 plus cosine. Since our x here is a 2x, we're going to want to multiply that x by 2. So it's going to be a 4x. It's going to be a 4x, cosine of 4x, all over 2 dx. Now I'm going to rewrite this whole integral as the sum, equals 5 halves. Try to do as many steps, as less steps as possible, but see what we can do. 0 to pi of 1 dx, which we know is just x, but I'm going to just write it all out so you can see. 0 to pi, cosine of 2x, cosine of 2x, dx. Okay, so this is going to be a plus 1/2, so plus the integral of 1/2 dx, okay, because I pulled a 1/2 out, which will leave us with a plus 1/2 times, remember these are all integrated 0 to pi, 1/2 times the integral of the cosine of 4x dx. Alright, so now that I have split all the integrals up, now we can easily take this integral and then evaluate everything at 0 to pi. Okay, so this is going to be equal to, I'll try to write this as straight as possible, 5/2, okay, times the integral of 1 dx is just x, plus 2 times, well, the cosine of 2x, the integral of cosine of 2x, is going to be sine of 2x divided by 2. So these 2's will end up canceling and will give us a sine. Here, I'll write all that out so you can see what I did there. So I'm going to have 2 times 1/2 the sine of 2x. Okay, this is because when you take the integral of cosine of 2x, you got to multiply it by the reciprocal, you got to divide it by the derivative of the argument of the function. So you're going to end up having this 1/2 and the 2 canceling out to just a 1 times the sine of 2x. Okay, so now we're going to have plus the integral from 0 to pi of 1/2 dx is going to give us a 1/2 x. This 1/2 x and this x are going to end up going together. So plus, okay, we're going to have 1/2 times, alright, so the integral of cosine of 4x is going to be the sine of 4x divided by 4, because so we're going to have 1/4 times the sine of 4x, okay. Here's our integral. I'm going to move this down a little bit. Alright. So now since we have all this is going to end up becoming a 1/8 sine of 4x. So we're going to have, I'm going to distribute this 5/2. So 5/2 times x, 5/2 x, plus, okay, we're going to have a 5/2 sine of 2x, plus, forgot to combine those, but 5/2 plus 1/2 is going to give me a 5/4. Okay, so 5/2 plus 5/2, 5/2 plus a 5/4 is going to give me a it's going to give me a 10, yeah, 10/4 x, okay, plus 5/2 the sine of 2x. Sorry. Okay, I already removed that. I just combined 5/2 s and 5/4 x, bring them down here. Okay, so plus 1/8 the sine of 4x. Okay, and we want all of this evaluated, remember, from 0 to pi. So we're going to get 10 times 10/4 pi plus, something went wrong over here. So 1/2 plus 1 is going to be 3. 1/2 plus a 1 is going to give me 3/2 times a 5/2 is going to give me 15. This is a 15. This is going to give me a 15/4. There we go. That makes sense. Alright, so 15 pi over 4 plus, this is a lot of there could be a lot of mistakes, but plus 5 halves sine of 2 pi, x here is where the pi is, so this is actually going to cancel to 0 because the sine of 2 pi is 0, plus 1/8 times the sine of 4 pi, which again, sine of 4 pi is going to end up being 0, minus, okay, we're going to have a 0, this is going to end up zeroing out, this term, plus 5 halves, sine of 0 is still 0, so 0, plus 1/8 times the sine of 0 is going to be 0 again. So all this ended up working out to where all this canceled, and we're left with 15 pi over 4.